Okay, grade 8, so we'll finish off 6.7 with a couple of examples from the book. So if you can't quite read, make sure you follow along in your textbook as well. This example 1, talking about a field trip with a bus with a bunch of students, and it's represented, the number of boys and girls on the bus is being represented by this equation. B equals 24 minus G. So we're talking about boys and girls, not allowed doing that these days, but old textbooks. So if we want to figure this out and we want to create a table of values, then we can take that table of values and take the ordered pairs and graph it. So we have a few options here. We could just start putting in from 0 on to 24. We don't have to actually fill in the whole thing because you'll see the pattern. 24 minus 0, so if there was 0 girls, that would mean there was 24 boys. A little bit of common sense, right? If there was 1, that would mean there would be 23. If there was 2, there'd be 22. If there was 3, 21, and so on, right? We could actually fill that all the way in. Now you could get to the end where there could possibly be 23 girls, which would mean 1 boy, 24 girls, which would mean 0, and so the pattern kind of continues. Now, when we're graphing this, we can take these coordinates or these ordered pairs and we can plot them on the graph. So if we have the number of girls on one side, the number of boys on the other, make sure you pick a scale that's going to fit, right? So if I counted by 4, 8, 12, 16, 20, I'd kind of run out of space. So I have to pick something better. So maybe I'll count by 3s every time. So 3, 6, 9, 12, 18, 24. So that should work. Okay, on the other side, I'll make the same scale, 6, 12, 18, and I'm only going to need up to 24. Okay, so girls to boys, and now we should be able to plot some points on the graph. 0 to 24, right in the middle here would be 3 to 21, and then if I kind of kept this going, it would be 6 and 18, and you can already start to see that there's going to be a pattern here as I plot some of the points. Notice I'm not picking every single point, but I could actually fill in a few of these points, right? So I could put in 1 and 23 somewhere here, and then 2 and 22 would go here. So there'd be always 2 more in between. You don't have to fill them all in. We know that it's going to be a straight line. So talking about discrete versus continuous, this would be a discrete situation because we can only have whole numbers of boys and girls. We can't have 1.23 girls or something like that. Okay, so describing the relationship between the variables in the graph. For every 1 that the boys go down, the girls go up 1. Okay, so basically there's that relationship there. Okay, discrete situation in this case. Okay, example 2, we're not looking at really a situation, we're just looking at an equation. So anytime we're looking at an equation, any value works, and we'll talk more about that at the end. But here's our equation, y equals negative 4x plus 1, and we're asked to create a table of values from negative 4 to 4. So if I take x and y, I just plug that in, negative 4, negative 3, negative 2, and so on, all the way up to 4. Now the way we find the y values is we actually just take each x value and plug it in. Negative 4 times negative 4 is 16, plus 1 is 17. If I plugged in negative 3, I get 12 plus 1. And you're going to always start to see a pattern. Negative 2, that gives you 9. You can see that the pattern is that the next number is going to be 4 less every time. Okay, so as we get into the negatives, still going to be 4 less. And we'd have a bunch of points. We've basically created a bunch of ordered pairs or coordinates to put on my coordinate grid. Okay, so if I can create the table of values, then I can graph. It's very, very difficult to actually take the equation and just try to predict what the graph's going to look like. So it's always important, even though it might not always ask for this, we still should do it. Always make the table of values, then graph it. Okay, for this graph, again, we've got to worry about the scale. We get from negative 15 to 17 this way. So we got to kind of take something that's going to make sense. If I do 4, 8, 12, 16, that's going to probably work nicely. And so then on the bottom, we're also going to get into the negatives. So negative 4, negative 8, negative 12, negative 16. Now you do have some freedom. If I made the y-axis labeled jumping up by 2's, I don't have to do that with the x value. For me, the x values are just jumping up by 1, so I don't have to make them go up by more than 1. It's gonna fit in my graph? We always wanna pick a nice scale that's gonna actually fit in my graph. So similar to positive and negative, we're gonna have positives to the right and negatives to the left when we draw a scale for this. So that's kind of the trickiest part with graphing, is we have to pick a scale that's gonna actually work for us. Okay, now we just have to plot points on the graph. So if we go -4 and then up to 17, keep in mind the scales, so we're kind of in between 16 to 18. -3 to 13, so again we're kind of in between. -2 and 9, -1 and 5, 0 and 1 should be there, 1 and -3. You can notice already, or you should be noticing, that we've got a pretty well straight line, and the neater you are with your graph, the more apparent it's going to be that your line is nice and straight. Okay, in this case I could connect the dots. Okay, it doesn't ask me for this, but it is a continuous relationship, because I could take any x value and I'd be able to plug in a y value. So if I just even took one for fun, 2.37, if I took the x value of 2.37, I could actually plug that in and I would get an answer. So -4 times 2.37 plus 1 is going to give you -8.48. So it gives me a coordinate value, and if I kind of map that carefully, it'd be tricky to actually plot this point, but it's somewhere here and somewhere here, -8.48. So somewhere it's going to appear on that linear relationship. Okay, so just showing that it is continuous, it does make sense. I can plug in any number and it'll give me a different number out for an input and an output. So the relationship between the variables in the graph, well, for every x value as it goes up, the y values are going down 4. That's actually not a coincidence, because that's a -4. That's why I'm jumping down by 4 every time. Okay, so a few questions for you to practice in 6.7, page 363, 6, 7, 9, 11, 13, and 14.